A cat crossed my path and then I fell in a ditch. This proves that I fell in the ditch because the cat crossed my path. What's common between Bill Gates, Mark Zuckerberg, Steve Jobs, Michael Dell? Successful tech entrepreneurs, billionaires, also college dropouts. What does it tell us? If you have passion, willingness to work hard, then college education is not necessary for success. Abraham Wald initially did not have security clearance, so much so that any document he would write would be snatched from him as soon as it was written because he was not authorized to read those himself. Taking a decision based on analysis of only success cases is wrong because it is ignoring valuable data points. This error in decision making is called survivorship bias. Is AI immune to survivorship bias? Far from it. In fact, AI can be affected by this bias at multiple levels. Hey there, welcome to Stay Curious with Saurabh, where we explore big ideas with humble curiosity. In the previous episode, I touched upon curiosity. The link is in the description. I ended that episode with a remark that success stories sometimes deceive us into taking wrong decisions. That is what I would try to dig a bit deeper today. And for that, let us time travel to the Second World War. Imagine Allied bomber planes flying over enemy territory, dropping bombs, but also getting hit. Most of those planes come back with a lot of bullet damage, and the rest don't come back at all, destroyed. The Allies are losing so many of their planes that they can't take it anymore. Something has to be done. So they decide to armor the planes, make them bullet resistant. But they can't armor the entire plane, can they? Think about it. Too much weight and the plane won't travel far or might not fly at all. So they have to choose carefully which parts of the plane should be armored. The authorities decide to take a data-driven approach. They take a plane's drawing and put red dots on it in those areas where the returning planes are getting hit. And they decide to armor those parts of the planes that tend to take the maximum damage. Logical, right? Let me park the story here and come back to it in a short while. Let's talk about something else meanwhile. What's common between Bill Gates, Mark Zuckerberg, Steve Jobs, Michael Dell? Successful tech entrepreneurs, billionaires, also college dropouts. What does it tell us? If you have passion, willingness to work hard, then college education is not necessary for success. It does not contribute to success, may even be a hindrance. Moving to another scenario. Don't lose patience. I promise I will connect all these as I proceed. Let us say you have a great killer business idea and you want to venture into it. But before you do so, you reach out to the people in your network who started their own companies and are successfully running it, trying to get tips of how to start, run, and scale a business successfully. Best source to get some advice, some best practices, right? The problem is that all these conclusions, these decisions to armor the planes, about college education, and tips for running business, these all are plagued by same error, survivorship bias. Survivorship bias is a form of selection bias that occurs when we focus only on entities or instances that have passed through a selective process, which is survivors, while ignoring those that did not. Let's go back to the bomber plane story, which by the way is a true story. The planes that were being studied had taken the most damage in its wings, tail, and its fuselage, the main body. Planes showed little to no damage in its cockpit or the engines. So it was decided to strengthen those parts that tend to take more bullets. That is till a statistician, Abraham Wald, called this out as stupidity. Abraham Wald was a Hungarian Jewish mathematician who had escaped to the US to avoid persecution during the Second World War. He then became part of the statistical research group in Columbia University and took part in addressing military problems. There is a fascinating legend about him. It is said that he initially did not have security clearance since he was considered an enemy alien in the US. So much so that any document he would write would be snatched from him as soon as it was written because he was not authorized to read those himself. Going back to plane armoring, Abraham Wald said that it would be a mistake to armor wings, tail, and fuselage based on this analysis because they were studying only the planes that came back, only the survivors. They had no idea where those planes were getting hit that did not come back, the ones that took fatal damage, possibly in the most vulnerable parts, cockpit and engines. Taking a decision based on analysis of only survivors or of success cases is mostly wrong because it is ignoring valuable data points. This error in decision making is called survivorship bias, a bias favoring the survivors. The mistake of focusing only on the visible successes while ignoring the invisible failures. It is often said that Abraham Wald's solution was simply to armor those parts that remained damage-free in the survivors, but that is oversimplification. His analysis was much more involved than that, and his proposal did result in improved survival rate. But we are not discussing here how to make planes more resilient against attacks. We are talking about a fallacy that all of us make in our judgments without even knowing. Survivorship bias is more prevalent than we think it is. We talked about college dropouts earlier. College dropouts turning into billionaire tech leaders, implying that college education is not necessary. This argument ignores the millions of other college dropouts who failed miserably. We also talked about getting tips from successful business leaders on how to run business, but doing that and possibly formulating your own strategy based on what they say worked for them ignores several other startups that might have failed despite having a very similar strategy. Say you want to lose weight. You look around and find a few people who successfully did that, have posted before and after pictures on social media. You ask them their routine, their regime, and copy that. Absolutely sure that if it worked for them, it will work for you. Survivorship bias. No one makes a post if they tried something, possibly the same thing, and failed. So those data points don't even reach you. You buy a book with title How I Turned a Lakh to a Crore in Stock Market in 5 years, and then follow those instructions step by step. Survivorship bias. Someone could have followed the same strategy and would have lost a fortune. And if that person ever decides to write a book, How I Lost Everything in Stock Market, he may not even find a publisher. Even nostalgia is affected. Many of us, or our parents, believe that songs, movies, or books from the past were better. Why? Because we remember the ones good enough to survive in memory, the bad ones forgotten. There are two related concepts that contribute to survivorship bias: the availability heuristic and the correlation causation confusion. Quite a mouthful, that one. The availability heuristic describes our tendency to use information that comes to our mind quickly or easily when making decisions about the future. Generally, this results in recency effect, meaning we give more weightage to recent events. But this could also result in survivorship bias as our brains are wired to cling on to success stories, especially success against all odds. No wonder most movies have the winning of an underdog aspect in some form or the other. And we love such stories. Success events become more readily available to our brains and hence play a bigger role in decision making. Hence, survivorship bias. The other aspect is if two things happen together, we tend to believe one happened because of the other. If A is correlated to B, then A must be caused by B. The correlation causation confusion. Every time I flick a switch, a bulb glows. That is correlation. But correlation alone does not prove causation. In order to prove that the bulb glows because of flicking the switch, you need to lean on physics. There is a very specific correlation causation fallacy called the post hoc fallacy, which comes from the Latin phrase post hoc ergo propter hoc, meaning literally after this, hence because of this. That is, if an event occurs after another event, and solely based on that someone concludes that the former event caused the latter one, then that would be a logical error called post hoc fallacy. Someone saying that a cat crossed my path and then I fell in a ditch. This proves that I fell in the ditch because the cat crossed my path. That is post hoc fallacy. Most superstitions form this way. If someone says that I took a cold shower every day at 5 a.m. and probably did a number of other things, and after a month I lost 10 kilos, and you start taking a cold shower at 5 a.m. without checking if this method worked for others or not, that is survivorship bias resulting from post hoc fallacy. Let me now steer away from human mind and step into the world of computers. Artificial intelligence. Is AI immune to survivorship bias? Far from it. In fact, AI can be affected by this bias at multiple levels. These days, it's not uncommon to see social media posts that say, ChatGPT changed my life. People have taken career advice, relationship advice, or even health advice from AI and then posted success stories online. They often praise the AI, but also subtly praise themselves for moving with the times, being smart enough to embrace technology. But what about the people who got poor advice or where the advice didn't work? Those stories don't surface as often, whether the advice was followed or not. That is survivorship bias. We are only seeing the successes, not the silent majority of failures or irrelevant responses that were quietly ignored. Now let's talk about AI systems themselves. AI models are built by training them on large data sets and then testing them on unseen examples. If the results meet expectations, the models are deployed or released. But what if the data used to train the model is biased from the beginning? Let me give you a real world example. A tech company created an AI system to screen job applications. They trained it using resumes of candidates who had been selected and hired in the past. Seems reasonable until you realize that that data set on which the model was trained had an overrepresentation of white male candidates from certain universities because of historic, possibly biased hiring practices. So the AI learned patterns that favored the same demographic and even penalized resumes with experiences or keywords it hadn't seen before, even when those came from highly qualified or diverse candidates. That's survivorship bias baked into data. The model learned only from the survivors, the previously hired, and never got to see who was overlooked or how they might have performed if given a chance. Now let me dive deeper into machine learning. It will involve some math, but I'll try to keep it simple and palatable. Say you're creating an AI to detect whether a tumor is cancerous. You gather a large dataset of 1 million tumor scans along with their actual diagnosis. You reserve 80% of the data to train the AI and 20% to test it later. These are your training set and the test set. The model is fed variables like size, shape, location of tumor, age and gender of patient, lifestyle habits, even things like ethnicity or hair color. You never know what patterns it might find. But suppose in your training data of 1 million tumors, only 1000 are cancerous. That's just 0.1%. Now, in real life, I would not want anyone to have tumor, let alone cancer, but such a skewed data set creates horror for the model. Now, let's say your model does something terrible. It learns to always predict that every tumor is benign, harmless, every single time. It is obvious that such a system is useless. Then comes the test phase. You feed it the remaining 20%, the 200,000 cases that you had set aside, the test set, which also have the same skew, that is 0.1% margin, which is 200.
Let's do a deep dive of test phase of model training. Total cases 200,000. Out of this, 200 are malignant and the rest benign. Let's look at the malignant cases and see what the system predicted in the test phase. Number of malignant predictions 0, because the faulty system is incapable of predicting anything as malignant, which means that the entire 200 were predicted as benign. Correct predictions 0, incorrect 200. Let us look at the benign set now. Again, nothing was predicted as malignant and everything was called out as benign. This time the incorrect count is 0 and the correct 199,800. You probably see where I am going with this. Out of a total 200,000 predictions that the system made, 199,800 were found to be right.
By the naive definition of accuracy, which is correct predictions divided by total predictions, this model is 99.9% accurate. As they say, even a broken clock is right twice a day. This broken AI system is right 99.9% of the time. This is a textbook example of survivorship bias in model evaluation. We are so focused on the correct predictions that we ignore the consequences of the mistakes, the missed cancers. Fortunately, in real-world machine learning, we use smarter metrics to evaluate a trained model, precision and recall. Without diving into the math, precision asks, when the model predicts something is cancerous, how often is it right? This model never predicted anything to be cancerous, so precision is 0. Recall asks just subtly different. It asks, of all the actual cancer cases, how many did the model catch? It caught none, so recall is 0 as well. So just to be accurate mathematically, precision in this case would be undefined, as it would evaluate to 0 divided by 0. But in the code, precision would be defaulted to 0. Keeping that technical detail aside, what's important to note is that even though accuracy says 99.9%, both precision and recall say that this model is a failure, and rightly so. That's why modern systems don't just rely on accuracy, especially with imbalanced datasets. Precision and recall protect us from being misled by survivorship bias and help ensure that we evaluate models not just by their success rate but by their failure cost. Why am I talking about survivorship bias? Am I trying to say that we should not take advice from successful people, not learn from their best practices? No, that's not what I'm saying. Then am I saying that we should also go looking for failures and fact check those best practices advice that we got from successful people? Not practical. May not even be possible because of lack of such data points. What I am proposing instead is that A, don't blindly copy anyone else's strategy, and more importantly, B, be open to the idea that it may not work for you. That mindset will force you to question and improve what you're doing. It will make you more alert, more adaptive. You will ask, you'll explore, you will stay curious. Before I end this, let me take another example and delve into something slightly contentious. Every successful person attributes their success to hard work and intellect. You rarely hear them say, I got lucky. Students clearing difficult competitive exams would go on describing how they studied long hours. But if we say that long hours would lead to getting good rank, are we saying that the students who narrowly missed did not put long hours? Isn't it possible that the ones who got through were just lucky? We will explore that in the next video. Till then and beyond, stay curious.